There's traffic in the sky and it doesn't seem to be getting much better. There's kids playing games on the...
Hi, today I'm going to do the 2015 higher level section C, question 1 in the DCG paper. Again, this is the geological geometry question. Right, so just to get started, again the usual here, the accompanying map located on the back page of section A shows ground contours at 5 metre intervals from an area of hilly countryside similar to that shown below. Okay, so again, intervals at 5 metres is a key point there for the contours. Okay, so ABC is the centre line of a proposed roadway and DEFG is a proposed car park. The roadway ABC has the following specifications. The section between A and B is level at 65 metres. The section from B to C is rising uniformly to a level of 70 metres at C. And the sides DE and GF of the car park are level. Okay, so using side slopes of 1 and 1 for the cuttings and 1 and 1.5 for the embankments, complete the earthworks necessary to accommodate both the roadway between A and B and the car park on the northern and eastern sides. The earthworks on the southern side have already been complete. Okay, so the first thing I'm going to do here is I'm going to mark in the ratios for my cuts and my side slopes, so the cut and fill if you like. So using side slopes of 1 and 1 for the cuttings, I'm just going to mark that in up here on top somewhere. So for every little triangle there, for every 1 metre you go up, this is for the cuttings, yeah, you go out 1 metre as well. So that's quite simple with that part. For the embankments, okay, so the side slope to the embankments, to the cuttings, and 1 is 1.5 for the embankments. So every 1 metre you come down, you come out 1.5. Okay, so as we're working at intervals of 5 metres between the contours, we'll convert that, so every 5 metres you go down, you come out 7.5. Okay, so no harm just to draw this on your sheets before you get started. And again, for the fill, it's quite basic, so every 5 you go up, you come out 5 metres from the road. Okay, just to get started, I'm going to work on this part here first. As we see, the section between A and B is level at an altitude of 65 metres. So from A to B here, as we see in our sheet, is level at 65 metres. Again, I'm just going to mark that in there, 65 metres. So I'm going to point out here that the contours here range from 55 up as far as 75. We know our road here from A to B is level at 65, which is from point 65 here over to the right, we're going to have a fill as the road is lower. So that means for every 1 metre, or sorry, every 5 metres we go down, as we see here, we go out 7.5 metres. So I'm just going to draw a vertical line out here from the contour line where it meets the road at 65, and I'm going to measure out my 7.5 intervals. Okay, I'm just going to draw in a few of them there, and I'll see that they're ranging from 65 at the road level and go down to 60, 55, 50. Okay, so that means we need 3 of those going out to it. So I'm going to draw those horizontal points across here. Okay, so just for a bit of clarity on that, I'm going to mark the heights on these lines as I move out. So 65 at road level will come out 7.5 millimeters, which represents our space as we go out. For every 1 metre we go out 1.5. So that line there would be your 60 mark. The next one, as we're going downhill, it would be 55, and we go down as far as 50. Okay, so it's back to the basics. That's the hard work, if you like, done back to the basics, plotting our points. So 65, move out to our contour of 60, out to our next contour. Actually, before we move out to the next one, you see the contour 60 is a line here, so that meets this one. Yes, sorry. Come out to the 55 mark, plot the points. Come out to our 50 mark here as well, plot the point, and we have our 50 here also. Okay, so I'm just going to draw in that curve. That basically is our fill slope plotted there. So I'm going to draw that in green just to keep the fill and the cut different As you can see, the 2 points on the 50 mark, you would curve that off. It doesn't come into a sharp point, if you like. Okay, so as that is a fill and it's going uphill as it comes towards the road, again we just put in our little tadpole symbols to symbolize the direction of the hill. Next step we need to work on is from the point at 65 millimeters over towards the left of the sheet. Okay, we know the road is at 65 meters, so the land up around from this point over is actually rising, so we're working now on a cut. So for every 5 meters we go out, we're going to go out, every 5 meters we come up, we're going to go out 5 as well. So I'm just going to draw in those points here as well. So it goes from 65 to 70 to 75. So I'm going to draw 3 of those in place. So 1, 2, 3, and I'm going to draw those lines across to the left. Okay, again, next thing I'm going to mark in is those if the road level again is at 65. We know we're coming up in height, so the next one out will be 70, and the next one 75. Sorry, it was actually only 2 of those that I needed. So plotting our points again, as we know this is now a cut, I'm going to use my brown marker. 65 at the roadside. Next one out moves up to 70, so where that crosses the contour line of 70, and you can see that comes back in around again towards the road, so I'm just going to plot it twice there. Next one out again at the height of 75. Again, that's going to be plotting on 2 points and back to the road here, which is at a road level of 65. So I'm going to plot those points again, and again a nice curve at the end where the 2 points are furthest out. Okay, so as this is a cut, I'm going to insert the tadpole symbols again just to symbolize in which direction the hill is rising. Okay, so the next step in that exercise, alright, that's the first part we've done. The section between A and B is level at an altitude of 65. Alright, the next step in that is the section B to C is rising uniformly to a level of 70 meters. Sorry. So from B to C, we're going from here to here, is at a level of rising from 65 meters up as far as 70 meters here at C. Okay, we're told the sides DE and GF of the car park are level. On here to this side from point G to F at this end of the car park, which we were told is level. Okay, so sorry, from point B to F. We're told that at point B here we're at an altitude of 65 meters along here. So if it's level, it means point F as well as at 65. I'm looking at the ground around here. We see these contours from this point. We're going from 65 down to 60, down to 55, and down to 50. Okay, so what I've done here, because the road is level, we know our contour heights here are running parallel to the road. And because it's running lower than the road itself, it's going to be a fill, which is coming out at 7.5 millimeters on our drawing. Okay, and like the last part, I've plotted those points and joined them up to form the curve. Okay, you see here it just finishes the curve at kind of in the middle of nowhere for now, but you'll see in a minute why that is done the way it is and why I've just covered in pencil for now. Okay, so I'm just going to move on and get back to that part in about 2 or 3 minutes. Alright, next part we're looking at is this part along here from the sides of the car park, point to F. Okay, we know that that is running the same slope as the road, which is coming from 65 meters up to 70. Okay, so at F we're at 65 meters, and at E we're at 70 meters in altitude. Okay, so likewise again, I'm just going to look here at 70, and we can see where the road is 75, 65, 60. It's kind of running similar to the slant of the road, but obviously we still have to do our cuts for that. Okay, because it's running at a slant. The way we do that is, there's a saying going when you have the hill, or you're doing the cuttings or the fill beside a hill, okay, the lines will actually run at an angle to the road to accommodate that hill. That's using and integrating the cone method. For that, what we do is we determine how far out we're coming out with those altitude lines, if you like. So we know here from the cut will be coming out 1:1, so it's going to be coming out at 5mm intervals. Okay, so to do this, I'm going to set the compass at 5mm. We're going to rotate what is going to represent our cone in plan. Okay, so the saying that we have for that is you cut at the butt and fill at the hill. Okay, so just to remember that, cut at the butt and fill at the hill. What we mean by that is, depending on the side of the hill you are, if you're working at the top here, you basically, it's a fill at the hill, so you're putting in your fill contours, if you like, starting at this side here where the cone is. You fill at the hill, so that just tells you which side you have to do it and draw your lines in it. Okay, so that there will give me the 5mm radius. Okay, so that will give me a point on that cone that I'm going to join back to here, to point F, as you see. Just while I have it in place there, I'm going to use the sliding set squares just to draw a line out there perpendicular from that in order to put our measurements on. Okay, so I'm going to, sorry, that was actually excuse me, that was at a 7.5 radius there, not 5mm for our cut. We're going 65 here in height as we go out down to 60 and so on. Okay, so again it's back to plotting the points. You know, this point here is at a level of 70. We move out to the next one and follow that contour back, which is 65. I'm going to plot that on both, 65. I'm going to come out here to 60, out again to 55, and out where this one crosses over. Extend that line on at point 50, so that's coming around from this side. So I'm going to join those again in pencil, plot those points, join through the dots, and you'll now see where it extends over the previous line. Okay, so the reason I left those extended and in pencil for the time being is to see where they intersect to find the actual finished fill line. Okay, so again I'm just going to draw those in green pen to determine where the fill line is. Okay, as you see, it's coming to a point there. That point would join back to this corner just to show you where the two surfaces meet. And again, one last tweak, we're going to put in the little tadpoles in the direction of the hill. Part B of this question, as you see I have done here, we were asked to draw the elevation of this triangular PQR, which represents a portion of the top surface of a stratum, and also to determine the dip and strike of it. Basically what I've done here is I projected the points P, Q and R up here into this space to create the elevation. We already started with our baseline of 20 meter altitude, so I put in a few extra ones those to move up to 25, 30, 35, 40 and 45 in order to plot these points. I plot those points, create this triangle in elevation. Okay, next thing I want to do is to determine the strike. So to determine the strike, you bring a horizontal line across from point Q here, as you see in red. This gives it an elevation. Project that down the plan to get the true length of the strike, as you see here with this red line. Okay, so that's the first part of part B, if you like. Next thing I was asked is to get the dip. Okay, so the dip we found we projected up here an auxiliary elevation looking in from a point view of the strike in this direction. Projected point R and point P and received our heights here from the elevation as seen here. This should give you a straight line with the 3 points and the auxiliary elevation. Draw another horizontal line across here just to determine the angle between the horizontal plane and your line PQR here, and this is your dip. Okay, you can measure that for 23 degrees I got, which will answer your question. So finally, the last part of this question, a lake is located in the area marked L in the southeast corner of the map. The surface of the lake is at an altitude of 50 meters. The line ST represents a central line and an overflow pipe from the lake. The pipe travels from the point S at an altitude of 50 metres to a manhole located at point T. The pipe falls uniformly at an angle of 10 degrees. Determine and indicate in metres the depth of the pipe vertically below the ground at point T. Okay, so see the line here of our pipe, which is ST or TS, whatever way you want to look at it. So what we're going to do for that, we're going to project our lines up perpendicular from that. Okay, I'm going to use an orange marker for this one, just for a bit of clarity. Draw our lines with our sliding set squares up perpendicular from point ST. Going to draw in our x1, y1 line here. Okay, we're told that point set S is at an altitude of 50 metres, so I'm going to come up here 50 millimetres, which is in here. That is point S. Okay, in the question we're told that the pipe falls uniformly at an angle of 10 degrees. Okay, so starting from S, just going to draw a horizontal line again across from S, and I'm going to get my protractor and set an angle of 10 degrees from that line. This here is our 10 degrees. I'm going to draw that line in here. Okay, so we're told determine and indicate in metres the depth of the pipe vertically below the ground at point T. So here we have point T, which is in this vicinity here. We know point T is at an altitude of 40 metres. So I'm going to measure up 40 metres here. I'm just going to draw a horizontal line there just to represent the manhole. Okay, so that's here, that is our manhole at point T. So how far is this outlet here below point T in metres? So it's asking vertically below point T, which will be along this line. And I am getting it here at 8.2 metres, so I'm getting 8.2, just above 8, so I'm going to say 8 metres here, depending on your accuracy with that, your distance between this point and this point here.